The nucleus of an atom will decay if the nucleus is unstable in some way. A decay always involves two simultaneous events. The nucleus changes to become more stable, and at the same instant, a particle or gamma ray is given off. Sometimes the nucleus is still not stable and may change again and again, giving off an alpha, beta or gamma each time it changes. But we're going to assume that it only takes one decay for a nucleus to become stable. For a given isotope, every atomic nucleus has a certain chance of decay each second. This nucleus has a 25% chance of decay each second, so you'd expect it to take 4 seconds to decay. And this is true on average, but we just can't tell for a specific nucleus. Sometimes it decays after the first second, sometimes it may survive for many seconds. In theory, it may never decay. Nuclei don't grow old. If it hasn't decayed after a given second, then it gets its 25% back. It's like tossing a coin. The chances of this throw coming up heads is always 50%, even if the last 1,000 throws were heads. When we have a large number of nuclei, by which I mean trillions, not just the hundreds we have here, each with a 25% chance of decay, then we know 25% of them will decay each second. We just don't know which nuclei will do the decaying. You can see that about 25% of the nuclei decay each time, but you can't tell whether a given nucleus will be part of that 25% or not. It's a common misconception that when a nucleus decays, the atom disappears somehow. But as you can see, this isn't true. The nucleus changes, but it's still there. The number of unstable nuclei goes down, but only because they've changed into more stable ones. The total number of atoms, and so the total number of nuclei, stays exactly the same. Radioactivity is a random process because you can't tell when a given nucleus will decay. You can tell how many nuclei will decay each second, just not which ones.